Good morning. Today we're going to see about the basics of an LED. LED is nothing but a light emitting diode. After the inventions of an your LED, nowadays the LED plays main role as a lamp, as a monitor, as a LED TV. So now we see the what is an LED, what is how the LED works, all those things in the upcoming slides. So LED is nothing but and comes under the family of diode. A diode is nothing but an electronic component which will have the two terminals and it will allows the current to flow in only one direction. And also we can say it is a simply the form of a switch. So when I'm coming to an LED, LED is nothing but a light emitting diode. It is also coming under the family of an diode. Here also we'll be having a two terminals, anode and the cathode. Anode is nothing but an a p-type semiconductor and cathode is nothing but an n-type semiconductor. And both the components are combined together will be forming and junction will be formed. Based upon the apply of an applied voltage or biasing, the diode will allow the current flow through the device or it will restrict to current to flow through the device. Based upon the components or material used, the LED color will change. So in each way it is differs from an incandescent or fluorescent or gas discharge lamp means it will not using any gas inside or it not having any filament and it will not having any moving parts inside it, and this gives an more advantages of an LED lamps compared to one other lamps. So when I'm coming to an basic or a brief history of an LED, it was developed in 1962 by an Hancock at GE. And during the 1960s, the only the LEDs are maximum used and designed, and it will be used, and it is actually used as an indicator in the electronic devices. And later 1970s, yellow as well as an green LEDs are manufactured, and it will be used in traffic light and exit signs as well as in digital watches. And where as a lamp, LED lamp, it will have more advantages than the other CFL and fluorescent lamp because it is more efficient optics. It is allowing and more efficient optics, and the quality of now we are getting an LEDs in the white color also. So quality of white LEDs are now comparable to CFL. It can able to give the brightness which is comparable to a CFL, and life is also comparably more compared to one other types of lamp CFL as well as incandescent. Advantages is it is not having any infrared radiation, it not give any ultraviolet rays, and it is actually mercury free, which you will be finding in the case of an your fluorescent lamp. And whenever the light outputs are improved by 35 percentage per year, and while the cost is dropped by 20 percentage by every year, the life of the LED lamp is improved, and the cost will be decreased. It can able to work in a cold environment, and it is not having a withstand with a, it can able to withstand with an impact or vibration. For example, if I'm going for an if I'm using an filament lamp, if you're going for giving an vibration or any light vibration, it leads to one damage. But in the case of LED lamp, we can't able to find any problem like this. And it is in digital, it will be easy for control, and we can able to use it as a user friendly. And when I'm coming to the working, how the LED works is it is similar to a normal diode. So what is when you're coming to the working principle of a normal diode, the normal diode will be having I told that it will be having two terminals, P type and N type. And P type is made up of P type semiconductor, N type is made up of N type semiconductor. And P type is called as an anode and N type is called a cathode. Whenever giving a supply, when you're giving a supply in such a way that you are forward biasing. What is meant by forward biasing is connecting an anode to the positive and connecting a cathode to the negative. When switching on the supply or a DC supply, so what will happening is the electrons. You can see this in the video. The white dots represents a p-type charge carriers, and the red dots represent the n-type charge carriers. When I'm giving a supply like battery with positive is connected to p-type and negative is connected to n-type, it's called as a forward biasing. When I'm switching on the battery, the electrons from the n-types will try to collide with an or mix up with an holes. During this condition, what will happen is a light will be emitted, light energy will be created, or we can say the ordinary diode, it will be liberated in the form of heat. But in the case of LED, it will be liberated in the form of photons. Photon is nothing but an is the smallest unit of light energy. Okay. And okay, when you're continuing with the working of an LED, when extra electrons in the n-type material fall into the holes in the p-type material, they release the energy in the form of a photon. The material in LED is selected so that the wavelength of the photon falls within the visible portion of the spectrum. So, in this case, the different materials produce the photons at different wavelengths as well as the colors. So, when I'm going for the types of LED lamp, there is various types are there. One is an indicator type and illuminator type, and we will be having an illuminator with the different types. And these are the two main types of LED lamps which are most probably used in the case of an real-time applications. So we can have the doubt that how they produce different colors. So the LED will be made up of various semiconductor devices along with materials like cyan, gallium phosphide, all those things. Based upon the materials added and the quantity of an material added, the color particular color will expose more, or the color will be brightness will be reduced. So when you have, if I want to have use a particular LED to produce a different color at the same time, same LED have to produce based upon the supply voltage, it has to produce different colors. Previously, we'll be having a different LED for a different color. Only that particular LED will give green, or that particular LED will give red, like that. But nowadays, we can able to use a LED which will be producing an and different color. Single LED can able to produce different colors. It is based upon the components used to design that LED as well as the supply voltage which is given to that LED. So now the in the case of an televisions and all, the three main colors are used. One is a red, green as well as blue. Based upon the combinations of red, green as well as blue, we can able to get a new color. So likewise, yeah, LED which can able to produce red, green as well as blue, and the component which is used differs the light, the color which will be produced.